Today we're going to talk about the Android development environment, an integrated set of tools to help you create your own Android applications. In our last lesson, I introduced you to the Android platform. I talked about how the Android platform is a software stack for building and running mobile applications. And if you've used an Android device to write email, to take photos, to get directions to some location, to play games, and so on, then you've seen the Android platform in action and you know what it can do. So the next question is, how can you use the Android platform to write your own Android apps? Well, one part of the answer is that you need to learn the details of the Android platform itself. And in fact, that's what we'll do throughout this class. Another part of the answer, though, is that you need to learn and master the tools that allow you to make use of the Android platform in order to create new applications. And that's what we're going to focus on today. The tools that I'm talking about are called the Android development environment, and you should think of them as your workbench for creating Android applications. And like any skilled craftsperson, the more comfortable you are with your tools, the easier it's going to be to produce top quality work. In this lesson, we'll cover several topics. First, I'll talk about downloading the development environment, or Android SDK, including the Android Studio Integrated Development Environment, or IDE, and assorted Android developer tools. And then I'll show you the Android Studio IDE in action, and together we'll create a very simple Android application. After that, I'll show you some specific tools, such as the Android emulator, which allows you to run Android apps without a physical device. And then I'll show you how to use the debugger to help you diagnose eventual problems with your applications. And finally, I'll show you a variety of other tools designed to help you further perfect your applications. Before you get started, make sure you have a supported operating system. For Windows, these include Windows 7, Windows 8, Windows Vista, and Windows Server 2003. For Mac, you'll need Mac OS X 10.8.5 up to 10.9. And for Linux, several distributions should work, but the Android SDK is tested on Ubuntu 10.04. And you can see the Android developers' website for more information about this. Now you should also make sure that you have the Java Development Kit version 7 installed. Again, check the following website for more information. Now, Google generally recommends that your development machine meet the following specs. It should have a minimum of 2 GB of RAM, but 4 GB is recommended. It should have at least 1 GB of storage for the Android SDK, emulator system images, and caches. And it should also have at least 400 MB of free disk space when it's running. Oh, and it should also have a minimum screen resolution of 1280 by 800. So now you're ready to get started. First, you'll need to download and install the Android SDK. And I suggest that you do this now. And that way you can follow along with my examples while you watch the rest of this lesson. And you can find the SDK at the URL shown here. And let me also point you to a short video put together by our friends at Amazon. The video is available at this link, and it'll walk you through the entire process of downloading and installing the Android SDK. Now, once installed, the Android SDK provides you with several things. First, it has at least one version of the Android platform, including libraries, reusable software tools, and documentation. It also includes the Android Studio IDE, which includes a number of tools that will help you develop, run, test, and debug your Android apps. And it also has a system image for the emulator, so you can run and debug your Android apps without needing to have an actual device. In our last lesson, we talked about the Android platform in detail, so today we'll focus on the other 3 elements one by one. But before we do that, let's take a look at a very simple Android app called Hello Android. Here I'm showing my phone's home screen. First, I'll click on the launcher icon, and then I'll click on the Hello Android icon to launch the application. The application starts and displays the words Hello World. Now that's about as simple as it gets, but let's walk through the process of writing this Hello Android application using the IDE. Now this is my IDE open to full screen. Let's start by creating a new Android application project. One way to do that is to go to the File menu, then New Project. And once you do this, you'll see a series of dialog boxes that ask you for information about your application. On the first screen, let's enter Hello Android for the application name. Where it asks for a company domain, I'm using examples.course. The IDE will use that to compute the package name for the application. And here you can see that it reverses the company domain and then tacks on the application name all in lowercase. So in this case, you see the package name is course.examples.helloandroid. And the idea here is that package names created this way are less likely to conflict with the package names of other applications that might end up on the same device. Now go ahead and hit Next. Now this screen asks you what kind of devices you want this application to run on. Here I'll stick with phone and tablet, and I'll choose API level 21, which corresponds to Android 5.0, as the oldest platform this app will run on. And you can also see that at this time, very few Android devices are running API level 21 or newer. So in practice, you might want to choose a lower API level. Now I'll click on Next. This dialog is asking what kind of UI template files I'd like the IDE to pre-build for me. Here I'll keep it simple, and I'll go with a single blank activity. Again, I'll click on the Next button, and the next dialog asks how I want to name some of the application's source code file. I'll just accept the defaults here, and then I'll click Finish. Now the IDE will generate the application source code and layout files. Once it's finished, the IDE displays a file called activity_main.xml, which defines the application's user interface layout. And based on the contents of this file, the IDE will show you whatever it can about how this application will look when it runs. As you can see here, this app will display a simple screen with the words Hello World. Let's also take a quick look at the source code for this application. So first I'll open up the file mainactivity.java, and that opens up an editor window showing the contents of the file. Now I won't talk too much about this source code right now, except to say that when this application runs, the onCreate method of this class will be called, and that code will set up and display the application's user interface screen. So let's run this code to see what happens. Now one way to run an application is to click on Run in the application bar, then select Run App, and you could also just type in the keyboard shortcut Control-R to run the app as well. Now a dialog box pops up asking where to run this application. In this case, I only have my phone connected, so I'll choose that. And now we wait while the application is copied to the phone, and then run. And there you have it, your first Android application running on a device. Now the phone I just used is a Nexus 4. But let's suppose that I'd like to test out this app on a different phone, say the Galaxy Nexus. But I don't have one of those phones. In that case, rather than run out and buy a new Galaxy Nexus, I can just run Hello Android on an emulated Galaxy Nexus using the Android emulator. In order to do that, I first need to create the emulated phone instance that I will use inside the emulator. And these emulated phone instances are called Android Virtual Devices, or AVDs. So let's go back to the IDE and set up an Android virtual device corresponding to a Galaxy Nexus. So now we're back in the IDE. First, I'll go to the toolbar and launch the Android Virtual Device Manager. It's a bit hard to see here, but look for the icon that shows an Android in front of a device. Clicking that will display a dialog box showing existing virtual devices and allowing you to make new ones. Let's create a new virtual device. To do that, click on the Create Virtual Device button, which will bring up a new dialog box. And I'll start by picking the Galaxy Nexus device definition, and then I'll click Next. Now I'll pick a system image for the device, and in this case, let's use a Lollipop or Android 5.1.1 image that also has the Google APIs. I'm picking this image because it includes apps such as Google Maps, which I plan to use later in this lesson. Now, I'll click Next, and here under AVD name, you can give this new virtual device any name you want, but I'll stick with the defaults here. You can also click on Show Advanced Settings to do things like including a front or back-facing camera, or changing the size of the device's SD card, and things like that. Now I'll hit the Finish button, and the new AVD will eventually show up in the list. Now you can click on that to start that AVD. And at this point, you may need to wait while the virtual device boots up. I'll come back when it's done. Okay, and there's the home screen of an emulated Galaxy Nexus. Now that the emulated Galaxy Nexus is running, let's return to the IDE. This time, I'll install and run Hello Android on the emulated phone rather than on a physical device. So just like we did before, click Run, and then Run App, and a dialog box pops up asking you which device to use. This time, instead of selecting an actual device, I'll select the virtual device that we just created, and I'll click OK. The IDE will install the application on the virtual device, and then run it. And here you go, Hello Android running on the emulator. Now, as you can see, it's pretty much the same as what we saw on my actual device, but of course the styling's a bit different because my actual device is a Nexus 4 running Android 5.0, while this virtual device represents a Galaxy Nexus running Android 5.1.1. So today I've shown you that you can build applications like Hello Android on an actual device, inside an emulator, or both. And there are pluses and minuses with each approach. For example, the benefits of using an emulator include that emulators are cheaper than actual devices. You don't have to buy all the devices that you may want to test on. Also, unlike a phone, the emulator allows you to easily configure hardware characteristics, like the size of the SD card you have, the display size, and whether the device has a trackball. Also, any modifications you make are isolated to the emulated device, so you don't have to worry that your testing will mess up your phone or its data. On the other hand, emulators have some real downsides as well. In particular, the Android emulator is really slow, and that can be frustrating when you're trying to rapidly experiment and tune your app, and you have to wait for the emulator to start up and run. Also, some features are not well supported by the emulator. For instance, there's no support for Bluetooth connectivity, and no support for connecting accessories to the emulator via USB cables. Also, some software features aren't available by default in the emulator, so certain applications may not run on it. And finally, at the end of the day, the emulator is not the device. You can't really know how your app is going to look and perform on an actual device just by looking at how it performs in the emulator. So let's take a look at some of the advanced features that the Android emulator does support. For instance, you can configure the emulator to emulate the speed and latency of different cellular networks. You can configure the emulator to emulate different battery states, such as whether you're running low on battery power or currently charging the device. And you can also inject mock location coordinates to make testing of location-aware applications easier. And typically you'd use these features to help you test code that must respond to the environment or environmental events. For instance, applications are often designed to do different things depending on the battery level. Let's take a look. Let me show you how easy this is. Here I'm showing a terminal window and an emulator running a virtual device. In the terminal window, I'll use Telnet to connect to the emulator. And you can see the port number on which the emulator is listening in the emulator window's title bar. In this case, that's 5554. So I'll type Telnet localhost 5554. And now I'll set the network characteristics to emulate a slower edge network. Network, speed, edge. And notice that the cellular network status icon in the notification bar has now changed. Now I'll change it back to 3G by typing network, speed, full. And now I'll change the battery status to reflect a phone that is running low on battery. Power, capacity, 10. And again, you can see that the battery status indicator in the notification bar has changed to reflect the lower battery level. And you can also see that the device is currently plugged in and charging. Well, I can also change the charging status to indicate that the phone is not plugged in. Power, status, not dash charging. And you can see that the charging status indicator has gone away. I can also set the emulator's location to Washington, D.C. by typing in the following command: geo fix -77.04 38.897. And if I now open up the Maps application, you can see that it shows my location as Washington, D.C. The Android emulator also allows you to emulate networked interactions, such as receiving a phone call or an SMS message. Back in the terminal window, I'll reconnect to the emulator over Telnet, and then I'll give the emulator a command which will cause it to emulate an incoming SMS message. And that command is SMS send, then the sender's phone number, 301 555 5555, and then the text message itself. This is a text message. Now keep your eye on the emulator window to see what happens when I hit return. Here goes. And as you can see, the emulator's notification bar now contains an icon indicating that the emulated phone just received my SMS message. And we can pull down on the notification bar to start the messaging application to take a closer look at the SMS message. Android even allows two emulators to interact with each other. Here I'm showing two emulator instances running. In one, I'll open the phone application and start to dial the number of the second. The number of the second emulator is the port number shown at the top of that emulator window. In this case, 5554. And now you see that the second emulator has received the call and is ringing its user. So I'll pick up the incoming call in the second emulator, and you can see that the emulator's interface has now changed to reflect that the call is connected. Now, if one of the parties hits the hold button, that will also be reflected in both phone applications. And once the users are done with the call, I can hang up, and both emulators show that the call has been disconnected. And of course, that's just a few of the things you can do with the emulator. There are many other interesting features as well. And if you want to know more, I recommend you take a look at the emulator page on the Android developers website.